Modernage MCQs Physics First Year Unit 9 Physical Optics Part 4. If the breadth of central maximum is omega naught and first maximum is omega, then option A omega naught is equal to omega, option B omega naught greater than omega, option C omega naught less than omega, option D omega naught less than or equal to omega. The key is omega naught greater than omega. Therefore, the correct option is B. Reason. In diffraction, the intensity and breadth of bright bands decreases as we move away from the center of screen on either side. This is the reason why someone can found a few maxima on either side of the central maxima. Hence, omega naught is greater than omega. The wavelength of light is determined by Michelson interferometer by using equation. Option A, lambda is equal to 2p divided by m. Option B, lambda is equal to p divided by m. Option C, lambda is equal to p divided by 2m. The option D, lambda is equal to m divided by p. The key is lambda is equal to p divided by m. Therefore, the correct option is A. Reason. The formula derived by Michelson for the measurement of wavelength lambda by his interferometer is lambda is equal to 2p divided by m, where p is the distance moved by movable mirror for the m number of fringes. Hence, the wavelength of light is determined by equation lambda is equal to 2p divided by m. If movable mirror of Michelson interferometer is moved lambda by 4, then the path difference between two waves reflected by two mirrors will be option A lambda by 5, option B lambda by 4, option C lambda by 3, option D lambda by 2. The key is lambda by 2. Therefore, the correct option is D. Reason, when movable mirror moves lambda by 4, the wave approaching it travels an extra distance lambda by 4 before reflection and also travels an extra distance lambda by 4 after reflection from it. Therefore, the two waves from two mirrors will superpose with a path difference lambda by 4 plus lambda by 4 is equal to lambda by 2. Hence, the path difference between two waves will be lambda by 2. The movable mirror of Michelson interferometer is moved lambda by 4. If the lambda is equal to 5 nanometer, then the path difference between two waves reflected by two mirrors will be option A 1.5 nanometer, option B 2.5 nanometer, option C 3.5 nanometer, option D 4.5 nanometer. The key is 2.5 nanometer. Therefore, the correct option is B. Reason, when movable mirror moves lambda by 4, the wave approaching it travels an extra distance lambda by 4 before reflection and also travels an extra distance lambda by 4 after reflection from it. Therefore, the two waves from two mirrors will superpose with a path difference lambda by 4 plus lambda by 4, which is equal to lambda by 2, which is equal to 5 divided by 2, which is equal to 2.5 nanometer. Hence, the path difference between two waves will be 2.5 nanometers. The movable mirror of Michelson interferometer is moved 0.05 millimeter if the number of fringes shifted in field of view is 500. Then the wavelength of wave will be option A 200 millimeter, option B 200 nanometer, option C 200 micrometer, option D 200 picometer. The key is 200 nanometer. Therefore, the correct option is B. Reason, formula for wavelength is lambda is equal to 2p divided by m. Therefore, lambda is equal to 2 into 0.05 divided by 500, or lambda is equal to 0.0002 millimeter, which can be written as 2 into 10 power minus 4 millimeter or 2 into 10 power minus 7 meter, which is equal to 2 into 10 power 2 into 10 power minus 9 meter, or lambda is equal to 2 into 10 power 2 nanometer, which is equal to 200 nanometers. Hence, the wavelength of wave will be 200 nanometers. Two radiations of wavelength lambda 1 and lambda 2 are incident on a grating. The second order maximum of first wave coincides with the third order maximum of second wave. What is the ratio lambda 1 to lambda 2? Option A 1 by 2, option B 1 by 3, option C 2 by 3, option D 3 by 2. The key is 3 by 2. Therefore, the correct option is D. Reason, formula, d sin theta is equal to m lambda. Therefore, for the first wave, d sin theta is equal to lambda 1, and for second wave, d sin theta is equal to 3 lambda 2. Equating right hand side of the equations, we get 2 lambda 1 is equal to 3 lambda 2, or lambda 1 to lambda 2 is equal to 3 to 2. Hence, the ratio is 3 to 2. Note, in the equation of diffraction grating, d sin theta is equal to m lambda, m is equal to 0, 1, 2, 3, and so on, is called order of maxima, or order of lines, or order of images. Two radiations of wavelength lambda 1 and lambda 2 in the ratio 3 to 1 are incident on grating. Their maxima coincide. If lambda 1 is 30 nanometer, then lambda 2 will be option A 10 nanometer, option B 20 nanometer, option C 30 nanometer, option D 40 nanometer. The key is 10 nanometer. Therefore, the correct option is A. Reason, the ratio of wavelength is lambda 1 to lambda 2 is equal to 3 to 1, or lambda 2 is equal to 1 divided by 3 into lambda 1, or lambda 2 is equal to 1 divided by 3 into 30 nanometer, because lambda 1 is equal to 30 nanometer, which is equal to 10 nanometer. Hence, lambda 2 will be 10 nanometers. Two monochromatic waves of wavelength in the ratio 3 to 1 are incident on a grating. The third order maximum of second wave coincides with the wedge maximum of the first wave. Option A, fourth order, option B, third order, option C, second order, option D, first order. The key is first order. Therefore, the correct option is D. Reason, formula, d sin theta is equal to m lambda. Therefore, for first wave, d sin theta is equal to m1 lambda 1, and for second wave, d sin theta is equal to m2 lambda 2. Equating right hand side of the equations, we have m1 lambda 1 is equal to m2 lambda 2, or m1 is equal to lambda 2 divided by lambda 1 into lambda 2, or m1 is equal to 1 by 3 into 3, which is equal to 1. Hence, the first order maximum of the first wave coincides with the third order maximum of the second wave. The grating element of a grating of 5000 lines per millimeter is option A 0.2 femtometer, option B 0.2 picometer, option C 0.2 nanometer, option D 0.2 micrometers. The key is 0.2 micrometers. Therefore, the correct option is D. Reason, the grating element is the separation of two slits of a grating. It is calculated for a grating as D is equal to length of grating divided by number of slits, or therefore D is equal to 1 millimeter divided by 500, which is equal to 2 into 10 power minus 7 millimeter, which is equal to 0.2 micrometers. The path difference between two consecutive rays from a diffraction grating for second order maximum will be option A d divided by sin theta is equal to lambda, option B sin theta is equal to lambda, option D sin theta is equal to 2 lambda, option D sin theta is equal to lambda. The key is d sin theta is equal to 2 lambda. Therefore, the correct option is C. Reason, in the equation d sin theta is equal to m lambda, d sin theta is the path difference between two rays coming from grating and m is the order of maxima. Therefore, the path difference d sin theta between two rays for second order m is equal to 2, maximum is d sin theta is equal to lambda. Hence, the path difference will be d sin theta is equal to lambda.